Hello everyone, today we are starting your unit 2 and next topic is spread spectrum. Many problems arise when the normal communication systems is going to do its work. In the areas such as military communication, the information has the secured. That means an unauthorized user is not expected to access the information. Also, he should not be allowed to infer the communication by any means. Sometimes the hostile transmitter like terrorist can jam the desire or legitimate transmission. To avoid this, the channel should be immune to any external interference. Even in the non-military communication, the unintentional interference is caused by a user who is transmitting its information through the channel which is already being used. For encountering this problem, we can use the technique called as a spread spectrum modulation. Now, spread spectrum is SS. Spread spectrum refers to the system originally developed for the military application to provide a secure communication by spreading the signal over a large frequency band. The SS signal occupies a larger bandwidth than the normal signal. Therefore, name is SS. The spread spectrum signal invariably uses some kind of coding. The spectrum spreading at the transmitting or dispersing at the receiver is obtained with the help of the code word. The code word associated with an SS signal is independent of the information carried out by the signal. The most important point is that the SS signal is pseudo-random in nature. This makes it appears like random noise. Therefore, in the normal receiver cannot demodulate the SS signal. Only a specially designed receiver can demodulate it and recover the information. Due to this characteristic, the SS signal appears as a noise to any unintended receiver. Next is applications of spread spectrum. There are multiple applications are there. A few of them I have listed over there. First is to avoid intentional interference called as a jamming, to reject the unintentional interference from the some other users. This is possible to achieve by the assign a different code for a signal for various users. This type of communication which allows multiple users to share a common channel for transmission of information is called as a code division multiple access, that is CDMA. Third is to avoid self-interference due to a multipath propagation. A signal can take multiple paths while traveling over the communication channel for transmission to the receiver. The signal component followed the different path length which result in dispersed signal at the receiver. This is known as self-interference. This type of interference also can be suppressed by the using SS modulation. Fourth is in low probability intercept signal, that is LPI. The message can be hidden in the background noise by spreading its bandwidth using the code word and then transmitting the coded signal at the low power level. Due to this modification, the probability such as signal be intercepted or detected is reduced to the great extent. Hence, the spread and coded signal is called as a low probability intercept signal. And last is the in obtain the message privacy. The message privacy can be obtained by the superimposing a pseudo-random pattern on a transmitting message. And multiple other applications are there in the cellular telephony, global positioning system, wireless local area, and secure communication in military. Next is classification of spread spectrum modulation technique. The SS modulation techniques are broadly categorized into two categories named as averaging type system and avoidance type system. The averaging type system reduces the interference by averaging it over the long period. The direct sequence spread spectrum Dss system is an averaging system. The avoiding system reduces the interference by making the signal avoid the interference over the large framing time. The avoidance systems are further classified depending on the types of modulation used. Some of the avoidance type system uses different modulation techniques are frequency hopping system, time hopping system, chirp, and hybrid modulation system. Next are model for the spread spectrum digital communication system. The block diagram is shown in the figure. The operation of the model of SS digital communication system is the information sequence at the input of the system is binary information sequence. The same signal is recovered at the output of the system as output data signal. We have already discussed the role of channel encoder, channel decoder, modulator and demodulator. In addition to these basic building blocks of digital communication system, two additional blocks called pseudo random pattern generator are used in this system. One of them connected to the modulator on the transmitter side, whereas other is connected to demodulator on the receiving side. Both these generators are identical to each other. This generator generates a pseudo random or pseudo noise binary sequence. It is impressed on the transmitted signal at the modulator. Thus, the modulator signal along with the pseudo-random sequence travel over the communication channel. This sequence spreads the signal randomly over a wide frequency band. Thus, the output of the modulated is the spread spectrum signal. The pseudo-random sequence is removed from the received signal by the other pseudo-random generator. The operation at the receiver. Thus, the pseudo-random pattern generator operates in the synchronization with each other. The synchronization between this pattern generator is achieved before the beginning of the signal transmission. This is done by transmitting a fixed pseudo-random bit pattern which is receiver can recognize even in the presence of interference. Once the synchronization is established, it is possible to begin the transmission. Thus, in the spread spectrum receiver, the receiver can demodulate the transmitted signal if and only if a known pseudo noise sequence has been transmitted along with the information signal. Two types of interference are presented in SS, digital communication system, namely narrowband and broadband interference. The modulation techniques used are phase shift keying and frequency shift keying. In the PSK, phase shifted keying, then the PN sequence is PN is pseudo noise signal sequence generated at the modulator is used along with the PSK modulation to shift the phase of the PSK signal pseudo-randomly. The result signal at the modulator output is called as a direct sequence spread spectrum signal, that is DSSS. In the binary, FSK is being used, then the frequency of FSK signal is shifted pseudo-randomly. This resulting signal at the output of the modulator is called frequency hop, that is FH spread spectrum signal, that is FHSS signals. Now next point is direct sequence spread spectrum, that is DSSS. The most important advantage of spread spectrum modulation is that providing a protection against the externally generated interfering signal, such as signals are called as a jamming signal. In information varying, signal is made to occupy a bandwidth which is much larger than a minimum bandwidth required for its transmission. It will make a signal to appear like noise and blends into the background. Thus, the spread spectrum is method of camouflaging of the messaging signal. One of the method used for the widening the bandwidth of data sequence is to use the modulation. Operation of encoder in Dss Ss system, that is the input data sequence is passed to the or converted into the sequence by NRZ encoder. The NRZ signal is pseudonymized signal are applied to inputs product modulator. At the output product of modulator, we obtain the SS signal. The spectrum of the signal is quite spread out compared to the spectrum, which is narrowband signal. A data sequence is used to modulate a wideband pseudo noise sequence by applying these two sequence to the product demodulator or multiplier. Both sequences are polar form. According to the Fourier transform theory, the multiplication of the signal in the time domain result into the convolution of the frequency domain. Hence, the data sequence is narrowband and PN, that is pseudo noise sequence, is wideband sequence. Then the product sequence will have the spectrum which will be nearly same as the PN sequence. Thus, the narrowband signal will spread over the wideband and the PN sequence perform the role of the spreading code. The transmitted signal is the baseband signal. The spread spectrum signal is transmitted over the channel where additive inference is added to it and the signal received by the receiver. Next is the operation at the receiver side. To recover the original signal, the received signal is applied to the demodulator. The demodulator consists of multiple followed by the low pass filter. The multiplier is supplied with a locally generated PN sequence, which is exactly replica of the PN sequence used at the transmitter. The receiver needs to operate in the perfect synchronization with the transmitter. Next is features of Dss Ss. Some of important features of Dss Ss systems are: it provides a good security against the potential jamming or interpretation. The Dss Ss is extremely effective against the narrowband jamming signal. The narrowband communication signal can coexist with the Dss Ss signal. The Dss Ss signal is not very effective against the broadband interference. Applications of Dss Ss system. First is to combat the intentional interference, that is jamming. Second is to reject the unintentional interference. Third is to minimize the self-interference due to the multipath propagation. Fourth is in low probability of intercept, LPI signals. Fifth is in obtaining message privacy. And last is code division multiple access with Dss Ss system. Next is frequency hop spread spectrum signal. In the Dss Ss system, the NRZ data sequence or modulate PN sequence. The product signal is spread instantaneously in the frequency domain due to this process. The capacity of Dss Ss system are rejected intentionally inference jamming is dependent on the process gain by the PG. The processing gain hence increase if the cheek period is decreased with terms of permit a greater transmission bandwidth or more chips per bit. The problem is that the capability of the physical device used for the generation of PN spread spectrum signal puts a practical limitation for the maximum value of processing gain. Hence, the capability to combat the jamming. Under some operation condition, the maximum attainable process gain PG is not suffering highly for combating the jamming. Under such conditions, an alternative system called as a Fh spread spectrum is used, that is frequency hop spread spectrum is used. The principle of this system, the data is used for modulating the carrier. The data modulated carrier is then randomly hopped for one frequency to the other frequency. Due to this, the spectrum transmitted signal is spread sequentially rather than instantaneously. Types of modulator. Common modulator techniques used frequency shift keying, that is MFSK. The combination of frequency hopping and MFSK is known as FH MFSK. Types of frequency hopping. There are basically two types of frequency hopping. First is slow frequency hopping and second is fast frequency hopping. Slow frequency hopping. In slow frequency hopping, both symbol rate of MFSK signal is integer multiple of the hop rate. That means the several symbols are transmitted correspondingly to each frequency hop. And fast frequency hopping. In the fast frequency hopping, the hop rate is integer multiple of MFSK symbol rate. That means during the transmission of one symbol, the carrier frequency will hop several frequencies or the several times. Thus the frequency hopping takes place in a fast rate. Next is advantages of DSS system. In this system has a very high degree of discrimination against the multipath signal. Therefore, the interference caused by the multipath reception is minimized successfully. The performance of Dss system is presence of noise is superior to other systems such as Fhs system. This system is combat of the international inference jamming most effectively. Disadvantages of Dss system: with the serial search system, the acquisition time is too large. This makes the Dss system slow. The sequence generated at the P encode generator output must have the high rate. The length of such sequence needs to be long enough to make a sequence truly random. The channel bandwidth required is very large, but this bandwidth is less than that of Fhs system. The synchronization is affected by the variable distance between the transmitter and receiver. Next is advantages of Fhs system. The synchronization is not greatly dependent on the distance. Second is this serial search system with Fhs needs shorter time for acquisition. And last is the process of gaining PG is higher than that of Dss system. Disadvantages of Fhs system: the bandwidth of Fhs system is too large, it's in gigahertz. And second is complex and expensive digital frequency synthesizers are required to be used. Thank you.